like to welcome you again to the session about project management. I think we have 5 interesting papers, all papers covering somehow different aspects of project management or different perspectives, but I think that's an advantage, and that we could have a fruitful discussion from various viewpoints about project management. So I think you are already familiar with the procedure in each session. I think you all attended sessions previously. So firstly, after the introduction, we will play the presentations, and after that we will start the discussion. In the meantime, all of you are welcome to post the questions in the chat in the time when the presentations will be played or after, and according to this we will start the discussion. Please indicate to which presentation or which person the question is addressed, either by first name of the presenting author or the number of the presentation. So the first paper is about process modeling morphology to support process analysis and development in change processes. The authors is Theresa Ammersdörfer and David Inkermann. So Mr. Inkermann will be present and instead of Theresa. The second paper is about framework for it's complicated to read all these abbreviations. So framework for improved project scheduling and very complex method. It will be presented by Mr. Keuper, and the co-authors are Riesener, Kuhn, Lender, and Schuh. Then the third presentation will be given by Ms. Katharina Dieterich, and the co-authors are Spath and Ohlhausen. It's about collaborative iron triangle, a new tool for supporting project management in interorganizational research in development projects. So this is about reaching win-win situations when several companies are working on the same projects. And the last presentation will be given by Manish Arora, I think, instead of Deval Karya. It's about comparison of 2 methods, namely engineering design and lean startup innovation methodologies applied to development of medical devices. So I think now we can start with the presentations, and after the all presentations will be played, then we will start the discussion. Again, you are free to post your questions to the other presenters or authors in the chat, and please indicate to whom the question is addressed. So, Robert, we can start with the first presentation.
Hello, and welcome to my presentation, A Process Modeling Morphology to Support Process Analysis and Development in Change Processes. My name is Theresa Ammersdörfer, and I'm a research assistant at Technical University Clausthal. In practice, processes are often undocumented and thus not transparent for the various actors involved. This results in challenges, especially when process flows, methods, tools, or roles change over time and the actual state can no longer be retrieved. In practice, there are various process modeling languages and forms of documentation of process models. There are also different ways of looking at the process, which can lead to difficulties in the process flow. The difficulties can arise from process changes due to fast-moving internal and external process influences, such as the introduction of new methods, information flows, or the introduction of new roles and responsibilities. These affects the process models so that an adjustment is needed. We propose the following approach to support process analysis and development in change processes. We define change processes such as change in leadership. For example, bundled knowledge of one person is to be passed on to not slow down the decision-making process, and derive process modeling requirements such as new process milestones or process activities. Process models are intended to structure and visualize a process to show interactions and dependencies of activities, results, and responsibilities. Process modeling languages enable to generate process models needed to represent the actual state as well as intended changes. Now I would like to come to the use of process modeling. Modeling languages for process models are important to coordinate adaptations. Core task of these change processes is the management of dependencies between activities. It is important for organizations to appropriately select the type of process model to support adaptations of processes. The focus of this work is to develop an initial characterization of process modeling languages to support and to be used in change processes. If we look at the example shown, we see the original process which has to reckon with changes. The planned changes are then documented in a new process model to show the effects in advance. It is therefore important to select the appropriate modeling language. These process modeling techniques are characterized and structured using the model morphology proposed by Andreasen. The given criteria are allocated to the modeling activity and the resulting modeling language. This allows to match the requirements on the process modeling used in change processes with the respective properties of the selected process modeling languages. Therefore, the modeling languages for process models are characterized by the following parameters: objective, property, purpose, user, code, and medium. For the code, the user's level of knowledge in this environment is critical, so that the user can decode and understand the modeling language. The parameter medium in which the modeling language is created also contributes the characterization of the process model in order to show the classification by means of a selected example. The BPMN diagram is classified. If we look at the code column, for example, a predefined syntax and symbol semantic is given. However, we have not only considered one modeling language, but 10, as the next overview shows. The overview presents an initial characterization for process modeling languages in the form of clusters. This representation provides the development teams with an overview of an initial classification of their own affected processes during changes. Based on the morphology, a structure was proposed to support the selection of process modeling languages in change processes. The sequence of support options is presented here. In it, the morphology and the evaluation criteria can be used, especially in the third step. The targeted selection modeling language is done through the 3 evaluation criteria of information flow and transparency of information, the interaction level, process structure, and output quality, the quality of the output or artifact of a sub-process, in connection with the parameters from the morphology. This is shown in the overview on the next slide. A black dot is set if the modeling language can be assigned to the respective evaluation criteria. This would be the case of the information flow and the BPMN diagram, so that the dot is set and then the other field, property and code, are filled in. The suggestion result can be used to select the appropriate modeling language when process changes are necessary. The development of the proposed selection aid is based on the literature and initial findings of process modeling in collaboration with small and medium-sized companies. Currently, there are not findings on the applicability and support of the proposed selection aid in practice, as the paper refers to prospective phase of design research methodology. Further research will focus on identifying additional change scenarios and developing a process for defining requirements of process modeling techniques. Thank you for your attention and welcome your questions.
Hello and welcome to the presentation of our paper, Framework for FAMD-based Identification of RCPSP Constraints for Improved Project Scheduling. My name is Alexander Keuper and I'm from the Laboratory of Machine Tools of RWTH Aachen University, and I'm very happy to present you our results. I want to start with a short motivation, followed by the theory deficit, followed by our approach, and conclude with a short outlook. Product development of manufacturing companies face various challenges in today's VUCA. One of them is the vicious cycle of multi-project management. The reason for that is that the product development is a multi-project environment and many projects are carried out simultaneously. This leads to an increased workload, and increased workload leads to longer lead times of the single projects, and many projects miss their schedule. This is amplified by the VUCA environment, so the delays of the projects increase. If the delays of projects increase frequently, of course, a countermeasure would be to start new projects even earlier to have like a cushion to the actual deadline of the project. This leads to new projects starting before old projects are finished, and the workload increases even more, and this vicious cycle starts turning. An approach to improve the multi-project management is to have a closer look at the resource management. And in resource management, we have the opportunity to allocate people to these projects which are very fit to finish these projects in time. And to find these people who are fit to finish these projects in time, we must take a competency-oriented approach into consideration. Let's have a quick look at the scientific literature. We derived the theory deficit from a systematic literature review. We had a closer look at approaches from project management and data analytics. A few of them you can see on this slide. We found out that the resource-constrained project scheduling problem, which is an optimization problem commonly used in the context of project management, is able to improve the outcome of a multi-project situation. But there is no systematic determination of the influence of competencies on the duration or the processing time of a project activity, and especially not with empirical data. So there are no approaches which identify the constraints for the research. So now I show you how we want to approach this deficit. Our approach is a three-step approach. At first, we want to create a data set which we can then analyze by exploratory data analysis. We use the FAMD analysis, which is the factor analysis of mixed data, in order to find the relevant impact factors on the duration or on the processing times of project activities. And then we use this information we gain from the data analysis in order to create constraints for the project scheduling problem in order to improve the outcome and the accuracy of this optimization problem. In the first step, we want to create the data set for the analysis. Therefore, we need to assess the competencies of our resources and therefore need to operationalize the competencies in our company-specific use case. So we assign proficiency levels to each relevant competency and then assign elements which help us identify whether a resource possesses this proficiency level of this competency. Then we combine this with the project data, and we assume that in the project data we have information about the initially planned duration of activities and the actual time of activities, and therefore we can calculate what the time efficiency factor in this project was. And by combining this data with the assigned project members, from which we know now their competencies and the proficiency levels of these competencies, we have a data set we can now analyze. We used factor analysis of mixed data to analyze this data. In the data set, the competencies are the parameters, the dimensions. Also, we used additional metadata of the project, like the project team size, the age span of the team members to have further parameters. And then the analysis determines which are the parameters which gives us most information about separating good from bad projects. And this gives us the information on which factors have a high influence on a good performance, on a good execution of the project. We then use the kernel density estimation to estimate the time efficiency for a given combination of parameters. In this example, we have the age span of team members as a parameter within our dataset. The lowest number within our dataset is 2 years of age span, and the highest is 28 years of age span. These are the limits of our, as we call it, flexible constraint. If we then allocate team members to a given project, we get an age span for that allocated team, and then we look up in our kernel density estimation what time efficiency value is given at that specific parameter combination with the other parameters present in that project. And then we can multiply all the activity durations within that project by this efficiency value, which is then based on the empirical data of historic projects. Finally, let's have a look where we can use these flexible constraints. They can be used within the resource constraint project scheduling problem and contribute towards more precise prediction and planning of project activities. Since we now know, based on empirical historical project data, what project teams may lead to a time-efficient execution of projects, and then improve the trade-off decision between a project team with a higher availability and a project team with a better fit to that project's activities. Feel free to contact me if you want to exchange ideas about this topic. Thank you very much.
Hello everybody, this is Niccolò Becattini from Politecnico di Milano. As co-author, I'm also presenting on behalf of Harshika, Singh, Nikola, Horvat, and Stanko, Škec, the longitudinal study of teamwork quality we developed in educational context. The research takes place during an educational initiative that is structured according to the project-based learning approach. This slide summarizes the benefits for the learner of the PBL approach, which appears to be particularly suitable for the learning of engineering design principles and methodologies. This pedagogical approach has been the basis of an educational initiative funded by the Erasmus Plus program of the European Union. The consortium coordinated by the University of Zagreb also gathered its computing center CERSE, Politecnico di Milano, TUV, and the University of Ljubljana. Together, the partner worked for the design and development of a new learning platform for innovative product development suitable for blended learning, LPID. The PBL approach proposed in LPID required the students to address a design challenge at the core of the PBL approach and work in teams to improve both relational and technical skills. The project, in the light of the restriction of the COVID pandemic and coherently with the blended nature of the LPID platform, required the students also to collaborate and work in team in remote conditions. The analysis of the background literature also showed that the teamwork quality is essential for the efficient and effective delivery of the expected outcomes. However, there are no specific evidence concerning teamwork quality in a PBL course, and the need of consolidating results with experimental evidence about its impacts on team performance. These lacks constitute the basis of this research. The estimation of teamwork quality and team performance have been carried out through the activities delivered by 5 teams of 8 people each. They were composed by 2 students from each of the countries belonging to the consortium. The challenge the students addressed during the class was proposed by Siemens Mobility Austria and required the students to redesign the interior of a metro coach in order to provide flexibility for passenger capacity during rush hours and a comfortable experience. The acquisition of data about teamwork quality and team performance required the development of 2 different surveys. The one on teamwork quality requires the students to fill it their own by using a Likert scale where the higher agreement corresponded to the highest score, and strong disagreement the vice versa. The survey on teamwork quality scans 6 attributes: communication as frequency, formality, directness, and openness of dialogue; coordination as the synchronization among team members; balance as the contribution to the work according to each member's expertise; mutual support as the collaboration for task execution; effort as the amount of energy and resources the task demanded; and cohesion as the capacity to build and keep team spirit. The one on team performance, in turn, regarded phase-wise metrics related to the outcomes produced by the 5 teams at the end of each of the 4 main phases of the project. Professors and Siemens company experts evaluated the outcomes by each team, not the work of one single designer. The project was developed in 4 main phases as per the ones mentioned previously. The survey of team performance was carried out at the transition between project phases, or more likely 1 or 2 days after, to consolidate ideas. The survey of teamwork quality, on the contrary, was administered during the project and approximately every 15 days, with a filling in tolerance of 1 week from the moment of the notification the new survey arrives. The sampling points, 7, make it possible to run the study with a longitudinal perspective. This symmetrical matrix shows that all the constructs used for the evaluation of teamwork quality are positively correlated with each other. High correlation values, for instance, effort and cohesion, effort and mental support, are also coherent with literature findings in different contexts than the delivery of PBL education. The histogram on the left-hand side, in turn, shows that all the students, without any distinction of team of origin, use smaller scores to rate teamwork quality characteristics at the beginning of the course, and then increase their ratings for all the teamwork quality attributes as the project proceeds. The diagram on the significance of these results show that the more significant differences are for effort and cohesion at the beginning and throughout the whole project duration, with a general step change at sampling point 6 for all the other attributes. That is the end of the embodiment design phase. With a team-wise perspective, it is also possible noticing that independently from time of the project process is modeled here as a black box, the evaluation of these scores is significantly different between teams, for instance, E and A. The low range of variation within each team also show that they keep the interpretation of teamwork quality attributes coherent among teammates. Also on the side of p-values, it is relatively clear that some team, for instance A and C, had multiple voices speaking with different opinions, which are way less marked for team D and E. For what concerns the second research question, these diagrams, and especially the one on the left-hand side, show that there is a light correspondence between the scores gained at the end of the presentation of the process phase and teamwork quality. The histogram on the right-hand side, moreover, also confirms that the trends of teamwork quality and team performance scores are lightly correlated in time, while these evaluations are internally uncorrelated across the phases. In summary, this study provided additional evidence that the constructs for teamwork quality are effective also to explore its characteristics during remote PBL learning activity. For what concerns the first research question, the results show that in PBL courses, teamwork quality is significantly higher than at the beginning, also in terms of differences between respondents. Some teamwork quality attributes are varying with more intensity. Efforts varies phase-wise, probably also because of the different expertise required during the project. The communication and cohesion show a more marked difference among the team members belonging to the same team, showing also potential sources of conflicts. The results for the second research question show a slight correlation between teamwork quality and team performance, which is way much stronger at the end of the course, probably due to the familiarity the teams obtain with their mates compared to the very first meetings. Thanks a lot for your attention.
Welcome. I'm pleased to present to you today our paper entitled The Collaborative Iron Triangle, a new tool for supporting a project culture-aware management in interorganizational R&D projects. My presentation is divided into 4 parts. I'll start with a short overview of the research frame, then I will present the developed new tool, the Collaborative Iron Triangle. After that, I will show a conceptual approach with the Collaborative Iron Triangle, and at the end, I will draw a short conclusion and show research contributions, as well as limitations and avenues for future research. For interorganizational R&D projects, a project culture-aware management is a promising approach to support managers in dealing with project particularities. However, an important prerequisite for this kind of management is that the organizations involved in the project follow a collaborative strategy. Therefore, our research question is how to support a project culture-aware management in interorganizational R&D projects. Our research has shown that for interorganizational R&D projects, it is not sufficient to focus only on one iron triangle. Rather, there needs to be an iron triangle for each individual organization, which need to be aligned to result in project scope, cost, and time. This sets a framework within which a project culture-aware management can operate to support a successful project completion. So it is important to support this kind of management with a new tool, the Collaborative Iron Triangle. On this slide, you can see a template of the Collaborative Iron Triangle. The template shows on the left side exemplarily 3 organizations which collaborate in a specific interorganizational R&D project. Each of these organizations has an individual organization, communication, and coordination, pursues individual interests with the collaboration, and thus has individual desired project results. To achieve them, each organization contributes different resources and has a desired time frame for the project. On the right side, the template shows the Collaborative Iron Triangle. This is the iron triangle which is valid for the interorganizational R&D project. Project scope, cost, and time result from the alignment of scopes, costs, and times of the individual organizations. Project organization, communication, and coordination is carried out by a project culture-aware management. This template can be embedded in a conceptual approach which supports project sponsors in the initiation phase to find suitable partners and to enter into a firm collaboration agreement. In the first step, project sponsors could either follow an effectuation or a causation approach. By following an effectuation approach, they start with the problem they want to solve and contact those partners they already know. In contrast to that, a project sponsor who follows a causation approach starts with a defined project scope and contacts those partners that contribute the so to speak right resources to achieve this project scope. Then, in the second step, independently on the approach chosen before, project sponsor and potential partners fill in the template. Thereby, the interests are transparent to all potential collaboration partners, which is a key in a collaborative process. After that, in step 3, the potential collaboration partners find suitable solutions. When following an effectuation approach, the project sponsors from the individual organizations focus on an extension of project scope. When following a causation approach, they focus on the separation of the previously defined project scope. This separation needs to be aligned with the individual scopes. Independently of following an effectuation or a causation approach, project cost is extended and project time is leveled so that a complementary resource base and a current time frame results. So in step 4, the collaborative iron triangle illustrates a win-win project outcome, complementary resources, and a current time frame for achieving this win-win project outcome. This represents a firm collaboration agreement. During an interorganizational R&D project, it is important that a concluded collaboration agreement is continuously reviewed. Therefore, the resulting defined project scope, cost, and time from the 4-step partner finding process, which is illustrated here on the left side with the collaborative iron triangle, must be continuously reviewed regarding the individual iron triangles that are included there and are illustrated here on the right side. For this, interorganizational project members must meet regularly to see whether the individual interests and thus the win-win project outcome are still up to date. Thereby, they can continuously review whether the interests of each individual organization are consistently reflected in the win-win project outcome. Furthermore, they can see at an early stage if changes occur. Back to the research question, how to support a project culture-aware management in interorganizational R&D projects. A project culture-aware management can be supported with a conceptual approach, including a new tool, the collaborative iron triangle. It illustrates that at project level, complementary chains among the involved organization result, which need a coherent, inclusive management. Moreover, the collaborative iron triangle offers a new approach for handling critical issues, as for example a fair output separation or dealing with intellectual property. However, there are as well some limitations to consider. In current project management literature, there's an evolution from the iron triangle or triple constraints to competing constraints. So future research could focus on an extension of the collaborative iron triangle with further constraints. Furthermore, the collaborative iron triangle was not evaluated yet in practice. So the next step should be the evaluation of the tool, for example, with focus on a removal of legal hurdles or minimization of differences in organizational culture. Moreover, future research could apply the collaborative iron triangle in other settings, as for example for supporting collaboration among different departments within organizations. These are the references for the presentation. Thank you for your attention.
Hello everyone, I am Deval from the Indian Institute of Science, Bengaluru. Our team has worked on a comparative analysis of the engineering design and lean startup innovation methodologies. Innovation is a key driver for product success in today's competitive startup ecosystem. Several methodologies such as the systematic engineering design process by Paul and Weitz and the lean startup process by Steve Blank have been widely used to foster innovation. ED offers a systematic approach to design problems via a structured process, supported by appropriate design methods and tools with a focus at the product end. The user-in-the-loop approach to ED extends this and demonstrates the importance of engaging stakeholders at the end of each stage to validate and modify, if necessary, the path of product design and development. On the other hand, LS is an extension of the traditional lean philosophy from the manufacturing world and centers on customer development and refinement of business hypotheses through customer interaction. Overall, both user-in-the-loop approach to ED and LS have similar goals but employ different techniques to achieve them. Earlier works that have provided a comparative understanding of these methodologies are limited to a theoretical foundation and lack in the availability of practical guidelines. The objective of our work is to address this need by undertaking a comparative analysis of the ED and LS methodologies using 3 case studies. To do this, 3 medical devices under development at the Indian Institute of Science were chosen. These devices have the common objective of addressing an unmet clinical need within resource-constrained settings, and the study authors have worked on them as part of a larger research group. This common objective and design team is the basis for selection of these projects. After selection of the case studies, a set of criteria were derived from literature which serve as the basis for comparison. These criteria broadly include the general goals and specific focus of both methods, the approaches, specific process steps, as well as the respective outcomes. Upon analysis, it was seen that CS1 did not involve any explicit formulation and testing of hypotheses. Design outputs were tested against test cases derived from requirements. On the other hand, the use of coherent and falsifiable hypotheses about relevant variables was central to the process followed by CS2 and CS3. Longer iteration cycles were seen in CS1. They were undertaken after some concepts or preliminary prototypes were available. On the other hand, CS2 and CS3 saw shorter iteration cycles. Hypotheses were tested and modified much more rapidly. The team carrying out CS1 had access to structured tools for concept generation, whereas ideation was not a part of the process followed by CS2 and CS3. Instead, it was a business idea that was developed systematically and tested for market viability. Similarly, CS1 saw a strong focus on qualitative methods and tools for developing a thorough understanding of the stakeholders involved. But CS2 and CS3 mainly used qualitative methods to gain an initial understanding of the situation at hand. All case studies had a strong focus on the objective outcomes and development of the work. CS1 did consider a limited set of business aspects during the task clarification stage, but did not have an explicit focus on the business model. On the other hand, CS2 and CS3 had a very strong foundational focus on the same. Within CS1, collected user needs were interpreted and clustered based on an understanding gained by the authors. In both CS2 and CS3, the 5 whys method was used to understand the core aspects of the various concerns, attitudes, and viewpoints expressed by the customer. Within CS1, brainstormed concepts focusing on the novelty of outcomes were evaluated with a POC. Within CS3, MVPs were built and tested for each subsystem. Learnings from each test were used to improve on subsequent iterations, and continuous focus on market differentiation and positioning was maintained. While CS1 strived for solution neutrality in the task clarification stage, the process in CS2 and CS3 was highly dependent on validation of the solution, which was available before the process began. CS1 has undergone multiple cycles of prototype building and is currently undergoing in vitro testing prior to a pilot clinical investigation. The final envisaged output for both CS2 and CS3 is a startup. However, at the current point in time, CS2 has achieved problem solution fit, whereas CS3 has achieved problem market fit and requires further work for MVP building and testing. Through the comparative analysis, it was found that ED is less suitable for startups, where an optimal use of resources is critical for survival, as it lacks effective tools to evaluate the commercialization potential of the unmet needs. However, once a need is identified and established, structured techniques in ED can generate novel concepts and translate selected concepts to prototype for functional or user testing. In contrast, LS is found suitable for resource-constrained environments because it saves prototyping costs prior to receiving validation from the customer. While concept generation and prototype development does not fall within the ambit of the LS approach, it does allow for testing a product or a business hypothesis via an MVP. In summary, this work has provided a comparative understanding for innovators beyond the theoretical outlines presented in available literature for employing ED and LS approaches. This could potentially help innovators gain a comprehensive understanding of the methodologies and their respective nuances. It has been noted that the scope of the study is limited to a comparative analysis of the two methodologies and does not evaluate the effectiveness of each, which warrants a future empirical study. We thank our partners and funding agencies who have supported our work.
So these are the presentations. Now we should start the discussion. I would like to ask all the presenters to turn on your cameras, please. Thanks. Just Alexander turn his camera. I hope you all don't mind if we all call us by first name. Also, David, could you please turn on your camera? Okay, so we don't have much questions apart my questions, so my suggestion would be to start with question from Michael Voigt. This is for Alexander. You can see it in the chat. Could you read it?
Yeah, the question was about the research methodology and how the different literature sources were rated in an objective way. Since we rated them not only with fulfilled or not fulfilled, but also with partly fulfilled or almost fulfilled, etc. To answer this question, I can basically say that the fulfilled, not fulfilled logic was not detailed enough for us. So we choose to make this analysis more detailed, since there are many approaches which go in the similar direction, but then in the end they come up somewhere else. And to us it was not clear to either put them in the objective fulfilled or not fulfilled area. So we introduced some levels in between. And in detail, beforehand we clarified our criteria for the literature analysis. And then we said, okay, it's not fulfilled if it's not addressed at all. And then for the steps in between, we arranged what criteria or how the criteria must be fulfilled in order to gain the respective level of fulfillment.
Thank you. I have one question for you that I didn't wrote in the chat. To me, your proposal looks quite complex. How do you see the possible implementation in the industrial practice? How project planners could implement your proposal?
Mm-hmm. Well, one very important requirement in order to be able to use it is, of course, that you have a good database. This also addresses one of your questions in the chat. That this is, of course, a methodology which is not applicable to every company there is, but it has to be a company which has a solid database. And many projects in the past where a lot of data was collected, and the minimum data set which is needed is that the projects with the planned duration and the projects with the actual time that was worked on these projects is noted somewhere. And we also need the information which employees work in each project. And then we can with the retro analysis, we can see these employees, what characteristics did they have, what competencies did they have, and then we use this to build the data set, which then can be analyzed. And this, of course, is a big step which has to be taken before we can even start with the analysis. So it is best applied in a company which has a very solid database and a very structured database.
Do you have any experience that such companies exist? Do some companies really record all these informations? I assume that yes, that could be recorded or traced if suitable project management applications are intensively used.
Yeah, exactly. In the cases where we actually found a database which we were able to analyze, we weren't able to just pull it out of one system, but it was a combination of different systems and different data sets, and it needed some time to prepare the actual data set before we could start the analysis.
Okay, thank you. So we have also a question from Professor Epiger to Katharina. Could the same approach be used to address trade-offs within a single dimension of the triangle? For example, two teams face a performance trade-off between their components.
Yes, I think the same approach could be useful there. Because you have then a transparency with the tool, and you have transparent interests, and if all parties know the transparent interests, they can then also use this interest to find a solution for the trade-offs also within one component or also within one dimension of the triangle.
Thank you. I would like to continue then with my question. Could you elaborate more and explain the step 3 on the slide 5? This is, I think, the crucial step in the process where you apply effectuation and causation. How your tool supports, I assume these are complex negotiations, or how this works actually?
Yes, with an effectuation approach, you find a problem, or you want a problem to be solved, and with a causation approach, you have a defined scope you want to achieve, and the tool helps there because for example, with a defined scope, with the causation approach, then in the initiation phase, the project sponsors can find those partners that help them to achieve this project scope, and then they can find the interests and write down the transparent interests, and then they split the project scope according to the resources they bring in. And according to this, they can find then a win-win project outcome, so to say. And with effectuation, you have a problem to be solved. And then you also define the transparent interests. And then you extend project scope according to the resources. And then you also have a win-win project outcome.
So the other presenters have a comment or questions about that? So basically, this is a negotiation process between partners, and finally, triangle visualizes or help to visualize the results. Did I understood that correctly?
Yes, it supports the negotiation process, for example, in the initiation phase. and it can be visualized then with the collaborative iron triangle, but the collaborative iron triangle can also be used in other stages, not only in the initiation phase. So you can form this collaboration agreement then, and you can have a continuous review because you have it visualized in this firm collaboration agreement with the collaborative iron triangle.
Okay, thank you. Well, let's go to the first presentation. My first question would be: you said that you are focused on change processes to apply your methodology. Could that methodology be applied on improvements without changing the process, or when there is no change that triggers the need, but just to improve the current state of the process?
Okay, to pick that question up, I think it is in the first place important to understand what we are meaning by change processes. So changes in our consideration are both organizational points, for instance, responsibilities for different activities, but also methods or tools that are applied within the processes. And yeah, based on that, I think it is also suitable, our method, to improve existing processes, focusing on the activity modeling, for example.
Why are you focused on changes primarily?
So, okay, that is mainly the focus we have in the current research project, since we here are introducing methods and also tools from systems engineering. So we are introducing new methods, new tools into existing processes, and we say, or we speak about in that case about changes in a very generic understanding.
Well, I like your comparison of 10 languages or methods that you did. What is your opinion about possible combination or usage of more of them to support not only changes but project management in general, or to combine them, for instance, with project scheduling?
Yes, okay. So that was not a focus we had in the past. In the past, we had more focus on data handling within processes, so the data flows and also data storages. Actually, we don't have a focus on workflow management or workflow automation, for instance. Yeah, maybe that will be a focus in future, but not currently.
For instance, one idea came to my mind to combine DSM with project scheduling, or at least to in some phase of project scheduling to apply DSM method, and then after getting some results, the project planner could reschedule the task schedule or project schedule according to applying DSM method. That's just one idea that came to my mind.
Yeah, thank you for that idea. I think we will pick that up.
And maybe some similar ideas, other methods could be applied for some stage or for some phase in project planning and scheduling.
Mm-hmm.
Okay, I would like to see there are no other questions in the meantime, so I would come with my questions to Niccolò. What's my first question, please?
So, how the evaluation of team performance was done? That one. Based only on the quality of proposed solution and or some other criteria. So let me say that given the time frame of the presentation, I wasn't able to put everything inside it. So the detailed set of criteria that we use for the evaluation of the 4 phases are available in table 2 of the paper. So we had approximately 3 to 5 sub-criteria for each of the 4 phases that we use to evaluate team performance, and each of these sub-criterion aim at measure one of the possible output of that phase. So in order to avoid any trouble, I'm reading them. So for the task planning, so the product planning phase, so the very first stage, we had something concerning the user and market research carried out by students, the capability to run a benchmark of existing solutions, and the formulation of visions and functional requirements for the next stage, which is the conceptual design stage. For the conceptual design stage, we check the quality of requirements, because obviously they evolve during the project, the quality of problem clarification, the variety of proposed partial solutions, since we expect them to propose more than once and to combine them, the quality of the proposed concept, and the way they evaluated their concepts so that they choose the best one. The more we move towards the final stages, we had a general description of innovation of ideas, the level of detail of the solution, the capability of the solution to be attractive. So those were the metrics for team performance. So we really measured the outcome of the teamwork instead of looking at teamwork quality, so that we wanted to check these 2 elements in parallel and then to see if these are correlated with each other. So this leads me the chance to go to the second question, which is about the phase-wise correlation. We observed that during the very first phases, we didn't have a strong correlation between teamwork quality and team performance. Let me say that team performance was not bad in terms of evaluation, but teamwork quality was definitely worse than team performance. We saw that there was a partial alignment towards the final stages of the project. As we said, this is a longitudinal, longitudinal for how much it could be longitudinal a course carried out during a semester. But in a way, we managed to measure this in time. And we observed that towards the end of the project, all the students improved some of the elements concerning teamwork quality, and these were much more correlated to the final outcome. We didn't observe this kind of correlation with the final outcome, which was in any case good, during the first phases, which means that students during the first phases, they had to invest more time in making the collaboration really capable of being effective through communication, through the efforts that they need to invest in the project, cohesion. Obviously, it's something that I mentioned at the end of the presentation, which was not so good at the very beginning. And we also observed that through the different members that we have within the same team, we experienced some differences. So in general terms, let's say that the more we go ahead with the project, the more the students become a single unit that work with some coordination and good communication. At the very beginning, this was not happening, despite they were very focused on the final outcome and they managed to deliver something good, irrespectively of these troubles that they experienced at the beginning.
Okay, thank you.
Thank you.
I think that some correlations can be found between your results and between second presentation where the research is based on analysis of competencies in the team and I would like to ask the question of why you consider, Alexander, the age span in the team as an important factor.
That was basically just an example. So the parameters we consider are all the parameters we can influence by the resource management. So by allocating staff members to the different projects, we build project teams, and all the parameters we can influence with that, we want to put into the data analysis. So age span was one example. The different proficiency levels of the competencies is another set of parameters, but also imaginable are, for example, the different, how many different locations are the employees of this project based, or several other parameters. And we want to include all imaginable parameters which have a possible impact on the project performance. And then by the exploratory data analysis, we find which of these parameters actually do influence the project performance, and then we only focus on them. But for the explorative data analysis, we use all the imaginable parameters which could have possibly an impact.
Thank you. So let's go to the fifth presentation.
Hi.
Hi.
Can you hear me okay? Yeah.
Yes, yes, thank you.
Thank you for your questions. Yeah.
Can you answer the first question, why you choose to compare those two methodologies?
Yeah, I think it kind of originates in the kind of work we do in our lab, which is to do product innovation activities, which also include maybe thinking about the business models as well. And therefore, we tend to choose engineering design approach as well as the business development approaches where lean startup is also coming in. In prior works, we have also compared it against design thinking paradigms, which have been brought in as well for innovation activities. So all these three kind of club together in our work of specifically product innovation. That's why we choose to kind of compare them and see where as you pointed out, where they can be used simultaneously, where they complement each other, and that's, I think, important for product companies to look at. Therefore, we choose to do this comparison, and we find that there is definitely some synergy between them. Engineering design, as you see, is more technical oriented, specifically towards product development, whereas when you don't have clarity on what business model will work, approaches like lean startup would be more appropriate, where you start with the hypothesis and continue testing it and evolving it with the help of users. In prior work, we have also looked at engineering design approach with a user in the loop, where if you look at task clarification stage, it becomes quite similar to, there are some similarities of that with the approach of maybe design thinking paradigm as well, where you bring in the users, take their perspective, build a stakeholder map, and then proceed from that to evolve what the problem statement is and proceed from there. So we see a lot of synergy, and I think they kind of complement each other, specifically when you're looking at new products where business model is also not clear. So that's a scenario in which you operate. I hope that was clear.
Yes, thank you. I think there is a way to accomplish a synergy between these two methods that by applying some phases from one and another in a proper sequence or simultaneously, because one is focused directly to technical issues and the other to business issues, and together they surely should give a better result finally.
Right. Thank you. Is there any further clarification I can issue?
Well, are there any questions you would like to ask each other?
Not specifically. I think presentations were quite clear and well-organized sessions. I think. Thank you.
I think my impression is that there are related areas, and I think a lot of opportunities to exchange ideas and combine your research work in a kind of synergy where various methods could be applied together and to improve project management as a whole. So both analysis that are presented in the first paper, then a very detailed and complex mathematical model that's presented in the second paper, the study which has very interesting results regarding building of the team during the teamwork, which also has a great impact on scheduling the project and of course the forming of the teams and the tool for initial phase negotiations between companies and again a combination of two methods. There are a lot of overlapping issues here. Okay, so at the moment I don't have any further questions. This is the last call for any other questions from you or from the audience.
Well, no, let's say that I have just one small clarification according to what you asked, Neven, concerning the difference between the initial and the last phases. I also think that that difference depends on the fact that students are much more confident in carrying out the latest phase of design rather than the earliest ones. So that's why probably these things, as we carried out this kind of study on teamwork quality with students, we observed a much more higher correlation in the latest phase when students had to start working with CAD systems rather than during the very first phases where they need to use their brain rather than simply CAD systems. Or just their brains. And so probably that part requires a lot of negotiation, which is probably less difficult to achieve during the latest phases, when everything is already set and it's just a matter of deciding who's working on which part model and how to assemble everything together. So that's my comment that I probably needed to mention before and I didn't.
Thank you, Niccolò. And I forgot to ask one question to Katharina. What do you consider as culture-aware project management?
This is a management approach where project culture is in the center. So the project members define values, and these are then continuously controlled in a closed loop to set a project culture which supports them in achieving their project goal.
Thank you. Okay. We have 4 minutes left, but since there are no further questions, just to check the chat for the last time. No. Okay, then I would like to conclude this session. I would like to thank all the presenters. I would like to thank you for keeping the discussion alive. And good luck with further sessions and with your research work. Thank you again, and goodbye.
Thank you, everyone.
Thank you.
Thank you.
Thank you.